hard to see, but we're looking through a window here, and it looks like a real room, but it's actually a complete hologram. Very cool. And just to prove there's nothing there, there we go. That's the other side of the window. And you can see people peering through, and there's nothing there. Oh, and there's my wife, Nicole. Look, there she is. There you go. You wanted to see her on camera. That's her. She doesn't know I'm filming her. This could be funny.
Yeah.
See the car in the mirror?
Oh.
There's a car in there, apparently.
It's a Gemini.
It's a Gemini.
You can look in through the window into the
Oh yeah.
car,
I see.
and on the other side of the room you can see that in the room.
You can actually see into the other room, can you?
Yeah, you can see the car and the reflection of the mirror.
Oh. Oh yeah, you can too. Yeah, you can see the car in the reflection of the mirror. Wow, how does it do that?
Just capturing the full field, the full wavefront field coming from the scene. So the whole scene is illuminated with lasers, and they combine that then with a reference beam onto the panel, and all of the light coming back from the scene is recorded in the panel.
Right, we're on Phil. Phil's our token laser physicist. He does have a PhD in laser physics, and he's going to tell us how this works, maybe. How does it work, Phil? What are we actually seeing here?
Well, these are laser holograms, so they're created by interfering a single laser beam in a plate, like a photographic plate. The plates each have a holographic emulsion in them, and they record wavefronts. So the way that the holograms are recorded is you have a single laser beam that you split into two, and one becomes a reference beam which goes onto the plate, and the second one is directed into the scene. So then the light that's reflected off the scene interferes with the reference beam in the holographic plate, and the interference between the wavefronts on the plate is then recorded in the plate, and then it's just developed like it's similar to a photographic development process.
Oh, so there's actually an emulsion type developing process, kind of.
Yes.
Okay,
yeah,
so
very similar to photographic.
Right. So the actual plates are fixed. That's why they can't do animation or something like that. Right. Awesome.
And
Thanks
then,
for that.
And then to reconstruct the image, they have a laser beam which mimics the original reference beam, and then as that passes through the recorded wavefronts in the emulsion, then it reconstructs the original wavefronts from the scene, and then you can look into the scene and see the scene as it was when it was recorded.
Right. So this would have been a real scene.
This was a real scene.
This was a real scene that somebody has...
This particular one, the artist actually constructed the entire bar. It's a working bar.
Ah.
Constructed the bar within the National Acoustic Laboratories. So a very quiet, very stable environment. And they brought in a bunch of people. They had a party, and every hour or so they got everyone to move out, and they took an image of the scene. So you'll see as you look across the three panels, they're all from different times in the party.
Fantastic.
You can be sitting at the bar in real time and then looking into the mirrors but seeing the bar at a previous time.
Oh, no way. Cool. Well, you'd swear that's real, wouldn't you? Reach out and grab it. Fantastic. So there's the pool table in the background. There's the dartboard. And as we move to the next panel across, still see the dartboard, but now there's a You'll notice that the sign is over there in this scene. There's a sign which has that written on it. If we move to the next panel, and there's the signs moved over to there in this panel. So Phil, would you want to explain like how they actually set it up inside here? How they actually, where the actual glass panes would be, and how they set it up? Would you know that?
Well, this would probably be set up as you see it. I mean, the idea for the bar would be that you would be able to go and have a drink in this bar, and these plates would replace the mirrors at the back of the bar.
Ah, right, okay.
So
got it.
These plates would actually be placed at the back of the bar, and
got
then
it.
they would have laser beams coming from the top.
Yep.
That would be split as before. One part of the beam would be directed directly onto the plate.
That's what I was saying. It's quite.
Actually, maybe from this direction.
Yep.
And the other beam would then be split out to illuminate the whole bar itself. And then the reflected wave from that laser beam off all the items in the bar, hitting the plate, then gets recorded in the emulsion.
Oh, we've got the schematic diagram.
So you
very
can see
dark.
here, this is the bar. The bar's
Yep.
full table, so you're looking into the scene.
Yep.
And these are the holographic plates here.
Ah,
So the reference beam on the laser is then split into 3 beams, which each illuminate the plates. And
got it.
somewhere also, I can't see it at the moment, but that laser beam would also be used to then illuminate the scene itself.
Yep. And there you go, we can see that the depth of the room was actually 6 metres, but because we were looking through the window through here and we could see the reflection of the mirrors up the back, it's actually at least a